Okay, so to start today, we're going to talk about some special right triangles. So you study these in geometry, and we talked about them in Algebra 2 and how they relate to the unit circle. So this first one is a 30, 60, 90. The 30 has to be here. It's across from the short leg. The 60 is going to be across from the long leg. And generally, we say if the short leg is 1, do you guys know what the hypotenuse is compared to the short leg? Yep, it's 2. It's double. Yeah. So 2. And then compared to the short leg, this one would be root 3. Yep, because it's 1 times root 3. Okay, so you have your 30 degrees, your 60 degrees, and your 90 degrees. Okay, so across from the 30 would be 1, across from the 60 would be root 3, across from the 90 would be 2. Okay, we've also talked about these in terms of equations. So you can always say that the hypotenuse is equal to 2 times the short leg. Okay, and then the long leg is equal to root 3 times the short leg. For your 45, 45, 90, let's make our right angle here. Do you guys remember the isosceles triangle theorem? It says if 2 angles are equal, what else happens? The 2 sides across from those angles are equal. So let's say they're both 1. Do you guys remember what the hypotenuse is going to be? Root 2. Great. Okay, and that comes from the equation that the hypotenuse equals the measure of the leg times root 2. There's no short leg and long leg because they are the same here. Okay, so now we're going to look at special right triangles with the hypotenuse of 1. So if you have this 30, 60, 90, and the hypotenuse is 1, I'm going to have you guys solve to find your angle measures. So this, not angle measures, your side measures. Okay, so your angles are 30, 60, and 90. Okay, so you're going to solve to find the short leg. You know the hypotenuse. Okay, so if the hypotenuse equals 2 times the short leg, I want you to solve to find that. And then I'm going to call the long leg this fancy LL here. And then once you find that, you can plug it in to find what's across from the 60 degrees. Okay, so I'm going to give you a minute right now to do that. Okay, so what are you going to plug into the hypotenuse? 1. Yep. So when you solve, what do you get? 1 equals 2 times the short leg. You solve for the short leg, you divide by. Okay, so the short leg is always across from 30. That's going to be 1/2. Okay, and then here we just do root 3 times the short leg. Well, if the short leg's 1/2, we're just going to multiply those together. You do need to simplify. So when you multiply by the numerator. So it's just root 3 over 2. So don't leave it as the multiplication. So that would be across from the 60, and then we already did the across from the 90 is 1. All right, let's look at our 45, 45. So again, I'm going to give you the hypotenuse, and I want you to solve using the hypotenuse equals the leg times root 2. So you are solving for the leg. All right, so when you plug this in, you get the leg times root 2. You're solving, you're dividing by root 2. You don't want to leave the radical underneath, so we're going to rationalize. I'm going to multiply by root 2 over root 2. Okay, so your value of your leg should be root 2 over 2. Okay, so you have the square root of 2 over 2, square root of 2 over 2, and then this would be 1. All right, so we are now going to apply this to our unit circle. I do have some straight edges back there if you guys want to use a straight edge. If you're fine without it, that's okay too. We are just going to estimate. So if you had me last year, remember we used like this angle to find the 30 degrees and we drew them in. Okay, this year they'll already be there for you on the other side. Okay, but when you have your 30 degrees, we are going to draw in that triangle. And then we're going to talk about our different angles here. Okay, so you can estimate where 30 degrees is on your unit circle. Okay, and then the triangle is formed by bringing this down to your x-axis. Okay, so look at your 30-degree triangle. In your 30-degree triangle, we wrote down across from 30 degrees is 1/2. Across from 60 is root 3 over 2. If you're thinking of this in terms of the xy axis, the y-axis is always vertical, the x-axis is always horizontal. And those are going to be equivalent to the point on the unit circle. Okay, so if your x is root 3 over 2 and your y is 1/2, that's going to be your point. Okay, your point is x, y. Root 3 over 2, 1/2. Sorry, I know I wrote that kind of small. The cool thing about the unit circle is everything is just a reflection. So as long as you know the first quadrant, you can go ahead and fill in the other quadrants based on what we know about their signs, right? Yeah. Yep, so that's your root 3 over 2. So here would be another 30-degree angle. I'm going to have you write the points down there. Okay, this is another 30-degree angle. And another 30 degrees. Okay, so remember when you are doing your points, think of your XY plane. In the XY plane, everything in quadrant 1 is a positive Y coordinate, and a positive X. When we move into quadrant 2, this is the negative side of the X-axis, the positive Y. Here we have negative X and negative Y, and here we have positive X and negative Y. Okay, so based on that, I want you to fill in these points. And then we're going to go to the 45-degree triangles. Okay, this is a sheet that you'll be turning in, so take a moment to fill in those points. Okay, so if you apply the negative and the positive, you have root 3 over 2, and then 1/2. So they're the same order. The only thing that's changing is going to be your signs. Okay, here you're going to have a negative and negative. Again, it's the same exact ones. And then here you have a positive and a negative. All right, and then for the 45 degree, you have a triangle here. And we got root 2 over 2 for our x value and our y value. Okay, anytime you have a horizontal axis, that is going to be associated with the x-axis. Okay, vertical is associated with the y. Okay, so when you are putting those on your triangle, that is where your point is coming from. It's your x-coordinate and your y-coordinate. Okay, so again, I just want you to adjust those coordinates for every quadrant. Okay, so go ahead and fill those in. All right, and then for the 60 degrees, I didn't put a separate 60 degree on there because you can just turn this triangle. Okay, so for the 60 degrees, what happens with the x and the y's? They just switch, right? So now this is horizontal and this is vertical. So if I were to draw this triangle, right, if I were to draw the 60 degree triangle, it honestly doesn't matter which one you do. Okay, if you had 60 degrees here, now your x value would be 1/2, and this would be root 3 over 2. Okay, so it's 1/2 root 3 over 2. And all of these extend into the opposite quadrant. Okay, so it's the same point, it's just a reflection into another quadrant. Okay, so all of these are formed from this right triangle. This one isn't going to line up nicely. And I'm not sure if you guys remember like your reference angles from last year, but this is directly connected to those reference angles as well. Okay, so put your point in quadrant 2, in quadrant 3, in quadrant 4. I'm just going to make my reference angles. And then once you fill this out, I want you to flip it to the back. I don't want you to write anything down yet on the back, because I know that you guys will be ready to start with. Okay, so the first thing that we're gonna label on the other side is the first quadrant based on what we just talked about. Okay, so we talked about how if you have a 30-degree angle, how that is going to be a certain point. So I'm going to have you put the 30 degrees and then the reference point. So if you're looking at your reference point, you have root 3 over 2, 1/2. Oh, and I'm gonna color code. So I'm gonna do the degrees. So we have the 30, 45, 60. And then I'm gonna do my points in a different color. I just think it's easier to do the color coding so that when you look at it, it's easy to find what you're looking for because you'll be doing a variety of things here. Okay, so this is going to be root 3 over 2, 1/2. Okay, based on our second one, this would be root 2 over 2, root 2 over 2, and the 60 is going to be 1/2 root 3 over 2. We're also going to add in the 0 degrees, okay, and the 90 degrees. So one thing you might remember about the unit circle is it has a radius value. You guys remember what that is? It's 1. Yep. So for your unit circle, the radius is equal to 1. Okay, and that is going to help us fill in these 2 points. Because if the radius is 1, that means from a circle from the center to the edge, okay, the center to the edge would be a unit of 1. What would this point be? Close. 1, 0. Over 1, up 0. This one would be 0, 1. Over 0, up 1. Okay, what about this one here on this side? Why don't you fill that one in, this one in, okay, and then let's talk about some of the patterns. Do you guys remember how I told you you can remember this order without thinking about the special triangle? What do you notice about all the points for 30, 45, 60? They're all what? Every single one of them is what? Yeah. No, the points. They're all over 2, right? Okay, so all of the points have a denominator of 2, okay? Yes, I know you're thinking of the degree. Okay, and then, do you guys remember how I told you you can remember which one of these is which? Because these flip-flop, and sometimes we might second guess ourselves. Yeah, they go in order, right? What's the square root of 0? 0. What's the square root of 1? Square root of 2? Square root of 3? Root 2. Root 3. Yep. Okay, so when you're doing these, they're all over 2, and then wherever it starts, if it starts with 0, then it's going to go root 1, root 2, root 3. Root 1 is 1, so we simplify it. Okay, and then on the other side, it's the same thing. So you have 0, root 1, root 2, root 3. Okay, if you look at the degrees, those are going to be a pattern too. So you have 30 degrees, 15, 15, 30. 30 degrees, 15, 15, 30. Okay, so I'm going to give you some time right now. I want you to put those values in. So add 30, 15, 15. Okay, go all the way around your circle. And then I want you to put your points in. and if you're still finishing thumbs up, that's okay. I just want to also double check that you put the 360 degrees here. Okay, this is going to be the only spot that's going to have two of those values, okay? And then make sure you put -1, 0 here, 0, -1 here. And then all of your points are going to be reflections. Okay, all right, so I am going to give you guys a half sheet of paper, and we are going to do a few things before we talk about the radian values. Okay, on this half sheet of paper, we are going to convert degrees to radians and radians to degrees. Do you guys remember what the conversion rate is when you're doing the conversions? Yeah, 180 to pi. Okay, you could use 360 over 2 pi, but you would just have more to reduce there. Okay, so on your half sheet of paper, okay, you are just going to convert radians to degrees and degrees to radians. We're going to do the first one together. Okay, so this is going to be without a calculator. Okay, pretty much all of chapter 5 is no calculator. You're using a unit circle, a lot of patterns. Alright, so if you want to multiply by a conversion, remember that a lot of times when we use radians, you're going to have pi in it. That is not always going to be the case as we go further into chapter 5. Okay, but this is in radians. If you see the pi, it's degree if you see the degree symbol. Okay, so that means we're going to multiply if we want to convert to degrees over pi radians so that the radians cancel out. Okay, radians are not pi. It's just another way to measure an angle. A good way to think about it is that, you know, there are lots of things we measure in different ways, right? Like temperature. We can measure it in Celsius or we can measure it in Fahrenheit. That's exactly how it is with radians and degrees. There are two ways to tell you how large an angle is, okay? So when you do this, the radians will cancel out with the radians, pi will cancel out with pi, and if you can divide and do a shortcut, we're going to do that. So 180 divided by 9 is what? How many times does 9 go into 18? Yes, so this will be 20. What's 5 times 20 degrees? What's 5 times 20? 100. Okay, this is also something that you're going to be turning in, so I'm going to have you work on those next few. Now when you're ready to go to degrees, think about how your conversion is going to change a little bit. then when you're working with some of the bigger numbers, just try to take any shortcuts that you can. So we said that 180 divided by 9 was 20. Okay, the pi's are going to cancel. 20 times 20 is going to be 400. Okay, now when you get to the degrees, you want the degree to cancel out with the degree. So now we put the 180 on the bottom, the pi on the top. Brooke, what do we know about 4 or 5 and 180? They're both divisible by 5, so let's divide those by 5. That's where I would start. So when you're dividing something like this, works out nicely. How many times does 5 go into 40? 8 times. Okay, and then it's how many times does it go into 5? So you don't even have to do like the whole long division if you can see that, right? You could still bring it down and do it like that. Okay, so then this would be 81. And then let's do 180 divided by 5. So it goes in there 3 times with 3 left over, which means this is going to be 36. Okay, and then there's still a number that goes into both of those. Do you guys know? I guess we can keep off the degrees. Yep, divide by 9. So 9 pi over 4. Okay, and this one, did some of you guys know it without doing the conversion? It's one of our special points on the unit circle. It's just negative. So you can divide by 10. 3 goes into 18 how many times? 6. So you have negative pi over 6. Okay, so when you are thinking about your first quadrant, okay, if you have 30 degrees, that's going to be pi over 6. The reason why is 30 out of 180 is 1/6 of the circle. So for 45 degrees, how many 45-degree angles fit in the top half of your circle here? 4. Okay, so for 45, it's going to be pi over 4. Do you guys remember what 60 is? Pi over 3. Okay, so those we have to have memorized. Anything else we can factor. Well, and again, you don't even have to memorize them. As long as you can reduce and remember that it's over 80 degrees, that's going to be your fraction. Okay, so we're going to start. So 0 is just 0. Okay, and then we said this is going to be pi over 6, pi over 4, pi over 3. You did this conversion already. It was the second one you guys did. Pi over 2 was equal to 90 degrees. So this is going to be pi over 2. Okay, and then we know that 180 is equivalent to pi. We know that 1 full time around is going to be 2 pi. Okay, so there are lots of different patterns in here. I think the easiest thing to do is to count. So we're going to start with 90-degree angles. So if you're at 1 pi over 2, you're at 90 degrees. Where's 2 pi over 2? Where would 2 90-degree angles be? 180. Okay, and then if you went another 90 degrees, you'd be at 3 pi over 2, which would be at 270 is what you should have on there. Okay, and then 4 pi over 2 reduces to 2 pi. Okay, the next one I like to fill in is the 45. So this is 1 pi over 4, and then go 45 degrees to 2 pi over 4. Go 45 degrees to 3 pi over 4. And what's nice is 4 pi over 4 reduces to pi. Okay, then you have 5 pi over 4. 6 pi over 4 reduces, you already have it. 7 pi over 4. here, and then 8 pi over 4 would be back at 2 pi. Okay, if you wanted to fill in all the rest with reducing, you could count by pi over 6. This is 1 pi over 6, and then go another 30 degrees, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 4 pi over 6 reduces to 2 pi over 3. Okay, and then 5 pi over 6 is here. Okay, if you don't like the reducing, you can also just count by the pi over 3s because that's a bigger angle. So if you want to count by 60 degrees, it would be 1 pi over 3, 2 pi over 3, 3 pi over 3 is here, then go another 60 degrees to get to 4 pi over 3. And then the next 60-degree angle, you go 30, 30, would be here at 5 pi over 3, and then 6 pi over 3 would be at 2 pi. Okay, and then you can fill in your pi over 6. So if this is 5 pi over 6, this is 6 pi over 6. So we have 7 pi over 6, 8 pi over 6, we reduce that. 9 pi over 6, we reduce that. 10 pi over 6, we reduced. 11 pi over 6. Okay, so you can find all of your radians just by counting those values. You can also notice, hey, if they're across the circle from each other, their denominators are the same. These are over 6, these are over 4, these are over 3, okay, over 2. So that's a great thing to know as well. Okay, so remember that in quadrant 1, you're always going to have a positive x value and a positive y. In quadrant 2, you're going to have a negative x and a positive y. Quadrant 3 is where they're both negative. And quadrant 4, you're on the positive x-axis, negative y-axis. We talked last year, and we're going to be using this a lot this year as well, how points on the unit circle relate to our trig functions. You guys remember what coordinates relate to what trig functions? Yep, what coordinate's the sine, which one's the cosine? X is cosine. Good. Okay, so your points on the unit circle sorry, don't mind that little dash right there. Okay, your points on the unit circle are going to be the cosine of theta and the sine of theta. And that corresponds to your x and your y coordinates. Okay, the tangent, do you guys remember how to find the tangent? Using, yep, it's sine divided by cosine. So y over x. Okay, and then we had a little acronym to remember where the trig functions were positive. Do you guys remember the acronym? I'll give you the first one, all. A is for all. All students take classes, yes. And now that we've moved up in the ranks, the other thing you will hear people say is all students take calculus. Okay, and what that stands for is that all trig functions are positive in quadrant 1. The sine function and its reciprocal is positive in quadrant 2. Tangent and its reciprocal What is the reciprocal of tangent? Cotangent. What's the reciprocal of sine? Oh, not cosine. Cosecant. And what's the reciprocal of cosine? Yep, good. Okay, so we're going to be using those in 5.1. Today we're just going to start the first part of 5.1. We're going to be using the unit circle for that. And then I'm just going to start a new video for the